I have a broad range of interests, I would say, but I guess the thing that perhaps ties it all together is I'm a big fan of uncertainty. I'm more interested in what we don't know than what we do know, which in a way is kind of like being right at that boundary of what we call research, which is all, if you think about it, no matter what area you're in, it's about pushing that boundary. So within that very broad umbrella of what do we not know is a lot of stuff. In fact, most things we don't know, I think. And in physics, that obviously leads it, naturally into quantum for me, where, of course, not knowing has an entirely different meaning, where the idea of uncertainty is baked into the theory itself. So that took me to a whole new level when I started out to exploring this idea of uncertainty and not knowing and knowledge in general and how we describe the universe. But that, of course, also extends to questions of uncertainty about who we are and questions around identity and society. And all of that is, of course, very, very much intermingled. All of those areas actually interest me, and that's what I focus on in various research projects now. So this has been, I think, for me also a personal evolution where being uncertain sometimes is absolutely worrying. There's no doubt. It would be nice if we could predict our lives and our careers, for example, and things like this. We can't actually predict any of it, and that's not necessarily a bad thing. So for me, I guess quantum has really taught me deeply that there is power to uncertainty, that the universe itself is telling us, stop with all of this precision measurements and, stop with trying to know it all. The universe is saying, yeah, let's not be know-it-alls. And that's not a bad thing in the sense that we now, of course, have started harnessing quantum uncertainty and all of these weird quantum properties that we largely ignored since the beginning of the theory, which was developed over a century ago now. But only recently have we really started exploring and digging deeply into these stranger properties of superposition, entanglement, all of which have quantum uncertainty underlying them, and realizing that these are knobs and they are powerful tools that we can use to not only do information processing, which is, of course, the field of quantum computing, but also to dig deeper into what the universe really is, what exists, what doesn't. That to me really blows my mind to think about that. We actually have tools to even ask those questions, let alone answer them. For me, I wanted to flip it and say, no, that's exciting. It's exciting to know that we cannot ignore all of this fluid universe that we live in, and perhaps we should embrace it. So that's where I was going with that. So the theory is essentially what we call a probabilistic theory, meaning the fundamental description of any quantum particle, whether it's electrons or photons or any of these particles that we don't even see, is that we cannot actually know every quantity precisely. So if we wanted to know where it's going, then we don't know where it's located, or vice versa. There's this sort of balancing act all the time. And it doesn't matter how well we try to measure, we just can't. That's really what it means to be fundamentally unknowable. All we can do is talk about the likelihood of all of these different properties. So the fundamental question is, why is it that at the quantum level, that idea of uncertainty plays a much bigger role? It's not that we don't have uncertainty at our scale. It's just the scale is different. So at our macro scale, somehow quantum uncertainty doesn't seem to play a role. And there are many other processes that actually sort of wash out and wipe out quantum features such as entanglement and other cool things. And at the quantum level, if we have just these isolated particles that are not talking to the rest of the universe and we can sort of observe them and play with them, then we start seeing that these effects are big on that scale. So that's really what's happening. But that being said, a lot of times you hear that entanglement is about how there's some instant connection and there's something faster than light. That's not actually true. Of course, we have to be clear that there's no way to use entanglement or a connection between two quantum particles to communicate faster than light or transfer any information faster than light. So there are limits to what entanglement can do. But it is true that it's about connection between particles. That part is true. But what's really amazing, and the part that's different from regular connection, for example, you can think about connection as some kind of pairing, right? For example, a left glove and right glove, that's paired, or a knife and a fork. Those things are not surprising entanglement. We don't call them entangled cutlery. But there is something extra about the way that connection, the pairing works at the quantum level of electrons or photons and so on. And that is that not only is there this pairing of, let's say, That's going back to cutlery. If one of the electrons is like a knife, the other one's a fork. Sure, but what's interesting is that both of them already at the individual level have that uncertain fluid identity. So it's not clear which one is a knife, which one is a fork. In fact, they have this sort of possibility of being knife or fork, but we don't know for sure. So it's this combination where we don't know which is the knife and which is the fork, but if one is a knife, the other one's instantly a fork. Well, everything in quantum mechanics is about letting go of specifics and precision. The idea that science and the way we think about science can impact society is not new. As our science evolves, our social thinking also evolves. And for example, all of the Industrial Revolution and thinking around precisions and mass marketing and scales of how we think about things, as well as knowing exactly one thing or another, that has all absolutely shaped the way we behave socially as well. So to me, it feels like whether we like it or not, this whole new revolution with new quantum technologies that actually harness these stranger properties of quantum. We're already using quantum technologies, of course, the laser and electronics, all of that is based on quantum ideas. But now we're getting to the parts that we were kind of ignoring, like the uncertainty and entanglement. And once we start building that into our technologies and we're talking about these ideas more, it will absolutely, I think, inevitably shape this moving away, just like we move away in science from 0 or 1 and go to 0 and 1. Perhaps in society too, we will naturally start expanding our choices from right and wrong to a more broader spectrum, and not just right or wrong, yes, no, or anytime we try to have this sort of polar opposite kind of thinking. I think perhaps that will start evolving and we will get to newer ways and newer approaches which can influence so many aspects of our behavior, whether we're choosing what we want to eat at a restaurant versus our politics and our policies and so many aspects of our identities that honestly we are learning more and more are not about just one or the other. We are the intersection of so many different environments and influences and our own human characteristics that if you think about it that way, it feels narrow that we've not really embraced that kind of thinking already. I think so. I think it started as an idea revolution rather than about just the technology. This idea that you flip again the script of saying, let's ignore what we don't know, to let's embrace not knowing to be a tool, just like knowing is a tool. I'm not saying we ignore precision. Of course, we do need precision too. But that the combination is more powerful than ignoring one or the other. Mm-hmm. So I think that's the idea, the thinking of embracing these as extra tools, ways that we can deeply understand the universe as well as expand on our technologies and our applications. So I think, for me, that's the revolution. And maybe it will eventually lead to a bigger revolution that I think of as a social revolution, because technologies always end up going in ways that we definitely can't control, which is a little scary, but it always changes everything. I think it will be. The question is what kind of social revolution? One that can be, perhaps, we engage in it in a more knowing way where we understand in the history of science and technology, the way society develops hand in hand with technology gives us a lot of ways to learn how we could perhaps shape this next revolution rather than just get caught up in the flow. We will be anyway. But what if we could actually choose to be more structured and more, for example, deliberate and inclusive, for example, in the way we embrace and use these technologies, who has access to these technologies. So we do naturally already have some of these qualities, but we don't consciously acknowledge them. So perhaps that part will become more natural, where we allow ourselves to explore our thinking and how we make decisions and how we behave. Often what we do with technology, especially on the science side, and I'm sure we've all been guilty of it, is that we're so curious. We're like, let's just try it and see what happens. As we develop the technology, we don't have to limit what we do, but we should ask, what's the impact? Who's using it? Why are we doing this? Where will it lead? What's the environmental kinds of concerns we have? Is it sustainable? There's so many other questions. That's exactly the kind of what-if game that would be great to play. What if we could go back to the beginning of the Industrial Revolution and make a few decisions, key decisions? What would we have decided? Knowing everything we know now, what would we have done different? And from that kind of an exercise, can we learn something about starting this new revolution and ask, what if we use those kinds of lessons to try to put into place whatever are those key decisions and policies? It would require obviously some kind of ability to predict where we're going, and we'll never get that right. I think it's happening, but we don't necessarily then include that as we roll out the technologies. It's all being done in silos, which has always been kind of a problem with research. So here's a chance for us to break those silos. If there's a leader who's in a policy meeting, first things first, look around the table. Who's at the table and who's missing? That would be number one step. And it's amazing how much you can learn just from that alone. Because I don't think there's going to be one person who will be able to make all the right decisions. So find the team that can really bring in all of the skills and the expertise you might want to think about at least. It's something that's central in both to the physical world that we interact and to our social spaces, and just more broadly everywhere. Whatever we do, it's about how we interact with, whether it's other human beings or with other objects or even our imaginations and even things that are not there, that don't exist. Everything is about that interaction and then engagement. And that has everything to do with who we are and what shapes us. So to me, it is really an important piece that connects many of the projects that I work on personally, where other than physics, I do think a lot about who I am too as a person, because whenever we meet new people and we introduce ourselves, we say, hi, my name is so-and-so and I am such and such, right? And who am I, right? For one thing, the fact that am is the key word is already interesting. Instead of telling people what I do or what I love or what I'm interested in, we always lead with this is what I am, which honestly seems like, again, one of these very known concepts where somehow I'm supposed to already know that. I am. There's no room for uncertainty there. This is what I mean. It's built in, this idea of knowing everything. So questioning that automatically means questioning not just my own identity, but what does society mean about who I am, and whether I'm a physicist, or let's say I'm an immigrant to Canada, or a woman, or a certain age, or I have certain abilities, whether I'm healthy, or if whether I have. There's so many things I can't even think about all the different identities we have. So to me, it's important to explore that, and it can't really be separated out and say, okay, here I do physics here, and then I think about identity here. To me, they must connect, and they always do. When I was grad student physics, and I've talked about this often, where I did notice that it was kind of lonely because there weren't that many women in the room, and there were certainly not many people of color. I did all of my grad studies in the US, in the Midwest. But back then I thought, okay, who cares? That's not relevant. I'm in a physics classroom. I'm doing physics work. So if I do great physics, nothing else is relevant. That was my approach, that if I do physics, that's going to be everything. And it took a long time for me to eventually realize that it's not just about whether I do good physics or not, because it's not who I am and how I'm perceived does matter, and it's not necessarily always even a level playing field in terms of how your work is perceived or not. So even if I do great work, perhaps it won't really get acknowledged depending on who we are and who's there, and the fact that there are few women, and there's challenges, absolutely systemic barriers and challenges and biases that we all have that impact how we can do our physics or whatever other area that we're talking about. So that's how it started evolving, where I'm like, okay, I'm forced to face it in my own career and my own life. And then I realized that it's not just me alone. So the more I thought about it, the more I'm like, I don't know much about what it means to be a woman or a physicist and all of these identity questions. I'm not an expert on any of that. And all universities do exactly what you described, which is separate out. Okay, you go into the arts degree or the science degree, everything is very separate. So I didn't know students who were able to discuss these kinds of questions, and we're told to ignore it. So I was a very well-programmed science student. It took a while to break out and realize, well, maybe I should go find others who know more about this, which, it didn't happen until my early days as a junior faculty member, that I got to interact with other researchers from other faculties who were in psychology, social science, gender studies, and that really opened my eyes. And I realized, yes, there's research, there's expertise, I can understand more about these kinds of questions of context. And it went from there to eventually realizing I have to deprogram myself and try to think more holistically. And it does align with my physics in the sense that that's what I'm doing already in quantum, where I'm deprogramming from the 0 or 1 and trying to embrace this new framework of computing, a new way of thinking, which could absolutely be expanded to new ways of being broader in intersecting all of these different aspects. So what's quantum about quantum? So over the years, the systems I've studied to understand chaos have evolved. Turns out it's still one of the open questions in quantum, as in we don't quite know why we have this phenomenon that we see in the weather patterns and so on at our macro level, but we don't quite know how it manifests at the quantum level or if it does at all. That's a pretty big thing not to know.